Imagine if someone told you that 90% of all the stars you can see with your naked eyes were born before you were even born. It's not science fiction, but it's also not science fantasy. It's science scary. To be fair, they didn't just spring into existence one by one until now. Rather, star production peaked around 10 billion years ago when the universe was really young. That's when the cosmos was much more active, filled with gigantic gas clouds collapsing into new stars at a rapid pace. It was like one of those club nights where everyone is dancing on the tables. A time when it was difficult to look up in the sky without seeing a brand new star being born. But here we are today living in the twilight of this cosmic party, and our view of the night sky is slowly changing as the music fades and the lights come up. Since the peak of star formation 10 billion years ago, the star formation rate has been dropping steadily, going down by about 2% per year. And looking forward, things will get much darker for us humans. The universe will keep getting darker as the second star death dominates the cosmic night life. In about 100 billion years, our galaxy will be the only significant source of light in the night sky. But what's behind these dramatic changes? What does the future hold for the cosmos and our place in it? Let's dive into some serious space drama. We are living through a period known as the cosmic noon. The universe is in its middle age. We know this because we can observe other galaxies and calculate how many stars they have. Astronomers use a device called a photometer to measure the brightness of celestial objects. But let's face it, photometers are basically cosmic paparazzi, always trying to snap a pic of something interesting. When they point their cameras towards a particular area of space, they can identify the number of stars present in that region. But our cosmic photographers aren't interested in snapping pics of random stars. They're after the best, the brightest. They want to capture the stars that shine so brightly they outshine everything else in their vicinity. These stars are known as the stellar population. The thing is, not all stars are created equal. Stars at different stages of their life have different brightness levels. And our cosmic paparazzi are particularly interested in the turn-off point, the stage where a star stops producing energy and begins its slow fade into darkness. This point is crucial because it allows astronomers to figure out how old a particular group of stars is. Now, it's important to understand that when we talk about the age of stars, we're not talking about their lifespan. You see, stars don't have a specific age. They are born when a giant gas cloud collapses and continues to do the same thing for eternity. Rather, the stars themselves are like old cars. Over time, they go through periods of increased or decreased activity. For instance, a car might experience an increase in performance after an engine tune-up or major repairs, followed by a decline as it ages. In the same way, a star's luminosity can go through ups and downs. But unlike our trusty old cars, which rarely shine brighter than a headlight, stars can reach incredible brightness levels. When they shine brightly, they produce enough light to stand out from the rest of the crowd, allowing our cosmic photographers to capture them. But as they age, these stars begin to fade, eventually becoming too dim to be captured by even the best telescopes. And when this happens, they disappear from the pictures, leaving astronomers with incomplete data sets. This is why studying the properties of stars is like solving a cosmic puzzle. Astronomers have to piece together the clues left behind by these faded stars to understand how the universe evolved over time. It's like being a detective in space. So why is it that these stars are fading away? The answer lies in the fuel that powers them. As stars burn through their hydrogen reserves, they enter a phase of stellar evolution where they begin to fade. This process is gradual, but eventually they become too dim to be considered part of the stellar population. And this is where things get really interesting. You see, the rate at which stars fade away is not constant. Instead, it goes through ups and downs, kind of like a roller coaster ride through the cosmos. These ups and downs are not random. They are caused by external factors such as the availability of gas and the gravitational pull of neighboring stars. These factors influence the rates at which stars burn through their fuel, affecting how quickly they fade from view. For example, if a star is close to a massive star, it may be pulled out of its orbit and end up in a completely different part of the galaxy where the star formation rate is higher. This could expose it to more gas and dust, slowing down its fading process. On the other hand, if a star finds itself in a region with little gas and dust, it may start to fade away much faster. These external factors make the study of stellar populations even more complicated. It's like trying to track the movements of millions of particles in a fluid. Each star has its own story to tell, and understanding these stories can help us learn more about the evolution of the universe. By studying the properties of stars in different parts of the galaxy, astronomers hope to piece together the history of star formation and better understand the role that external factors play in shaping the lives of stars. But while astronomers are busy piecing together the past, the future looks bleak. You see, the universe is heading towards a period known as the second star death. This is a phase when most of the stars in the universe will run out of fuel and fade away, leaving only a few trillion stars to light up the cosmos. It's a bit like the final scene in a movie where the main characters have all died and the screen fades to black. Except in this case, the movie never ends. It just keeps playing with a much dimmer screen. During the second star death, the universe will be dominated by planets, white dwarfs, neutron stars, and black holes. There won't be any new stars to replace the ones that die off because there won't be enough gas and dust left over to form them. It's like trying to build a fire with a few dying embers and a pile of cold ashes. No matter how hard you try, you just can't get things going again. As the universe enters this dark phase, the night sky will become a graveyard of dead stars. The Milky Way, along with a few other galaxies, will be the only bright spots in the darkness. And for us humans, things won't be pretty. First off, there won't be enough light for plants to grow. Photosynthesis will become a thing of the past. And let's face it, without plants, humans will probably die off pretty quickly. But even if somehow we manage to survive, we'll be in for a real treat. The universe will become a dangerous place. You see, during the second star death, there will be a lot of planets wandering around without any stars to orbit. These rogue planets will be a hazard to any spaceship daring to venture out into the darkness. It'll be like trying to navigate a minefield, except instead of explosives, it's filled with deadly planets. To make matters worse, there won't be any stars to guide us. We won't be able to use the North Star to navigate, which means we'll have to rely on other methods of navigation, which is a bit like trying to read a map in the dark. We just won't have the same level of accuracy. It's a terrifying thought, but it's also an exciting one. As the universe enters this dark phase, we'll be living through one of the most dramatic periods in cosmic history. We'll witness the death of stars, the rise of rogue planets, and the beginning of a new era of cosmic degeneracy. But hey, maybe we'll come up with some cool gadgets to help us navigate the darkness. After all, humans are pretty good at adapting to change. Or maybe we'll just die off and none of this will matter. Who knows? All I know is that if I were planning a trip into space anytime soon, I'd bring a flashlight.